Hello friends, I am Tarak Shukla and we are talking about chapter number 1, 12th Science Physics exercise examples. Here we have exercise example number 1. What is the force between the two small charges and of a sphere having charges of a values 2 cross 10 to the power minus 7 coulomb and another one is of a charge 3 cross 10 to the power minus 7 coulomb. Both are separated by the distance of a 30 centimeters. First of all, I am bifurcating those data which has been assigned to us 2 cross 10 to the power minus 7 coulombs and Q2 is a 3 cross 10 to the power minus 7 coulombs. Our distance between them is denoted by the distance d or r. It is called as a 30 centimeter. So I can just directly say that 0.3 meters, or for your summarization I am just putting that minus 2 centimeter is converted to the part of a meter. Now I want to find it out what is the force between them. F equals to kq1 q2 divided by r square. But right now they have used that part if we have a place our charges in the air. So we can say that k is equals to Coulomb's constant 1 upon 4 pi epsilon 0. It is having value 9 cross 10 to the power 9 SI, or you can remember this unit because sometimes it has been asked for the dimensional configuration. So it's a dimensional configuration point of view and a unit point of view. It is having unit SI, or generally it is called as a Newton meter square divided by Coulomb square. Right now I am placing this value because I want to only find it out the force. So 9 cross 10 to the power 9, 3 cross 10 to the power 7, 2 cross 10 to the power minus 7, and the distance is called as a 0.3 square. So we can get that amount of force by calculation 10 to the power minus 7 minus 7 minus 14 minus 14 and 9. So we can have 6 cross 10 to the power minus 3 newtons. That's quite simple one. Next one is called as a second example. The electrostatic force on a small sphere of a charge that is called as a 0.4 microcoulomb, and due to another small sphere of a charge minus 0.8 microcoulomb. Students, be careful. Sometimes they will use this word sphere to just confuse you. It is not a sphere because we are aware that our charges are tiny droplets. If we go in a very microscopic level, we can say that it is having the nature of a sphere. So we can just, for our simplicity, remember that sphere of a charges, it means that it is only merely a charge. We have a first of all Q1 that is called as a 0.4 microcoulombs. Another charge Q2 is a minus 8 microcoulombs, and our force between them is called as a 0.2 newtons. We have to find it out distance between them. So first of all I am using this notation F equals to K Q1 Q2 divided by R square. If Q1 Q2 by R square, we want to find it out R. So R square equals to K Q1 Q2 by F. Again in the terms they have used that word, it is in the air. So value of K is standard value. So I am mentioning that K is equals to 9 cross 10 to the power 9 times SI, or you can use this word Newton meter square upon Coulomb square. Putting those values, R square equals to 9 cross 10 to the power 9. It is called as a 0.8 microcoulomb, so 10 to the power minus 6, and into we have a 0.4 10 to the power minus 6 divided by F. It is called as a 0.2 newtons. As we have R square, that is called as minus 144 cross 10 to the power minus 4 meters. But we are aware that whenever we are finding it out, a square root of it, there would be a negative sign can be removed. So it would be 12 cross 10 to the power minus 2 meters, or you can say that it is a merely 12 centimeters. One more thing they have asked us over here is called as what is the force on the second sphere due to the first one. We have found it out force by the first on the second one. Now we want to find it out opposite, or you can say vice versa. It is following Newton's third law. If it is following Newton's third law, then we can say that the same amount of force can be applied. It is 0.2 Newton. But only the thing is that also followed over here is called as a direction from the second to 1 is called as opposite. So you can say that here we have r equals to 12 cross 10 to the power minus 2 meters. So I have one charge over here, one charge over here. So it is applying force of direction would be from left to right. If my charge second one is over here. If my second one is applying force on the first one, its direction will be opposite, but the amount of a force will be same. So this is called as the end of a second example. Moving further, another important example of this chapter, which is dealing with the our previous some of the important concepts, because in this part we are dealing with the some of the physical quantities which we have learnt in 11th science. Check the ratios of a K square, G mass of electron, mass of proton, and we have to find it out. It's a dimensionless. We have to prove that because it is the ratio. So we are just dividing this part. Very first thing is our K square divided by GE mass of electron, mass of proton. So first of all we will just use a unit part, and thus we can have another part that is called as a value part. I require Ke mass of electron, mass of protons unit, or you can say dimensional configurations. So first of all, K is called as a dielectric constant, or it is called as a Coulomb's constant. So I have its a dimensional configuration is called as M1, L3, T minus 4 and A minus 2. You are very much aware about its unit is called as a Newton meter square upon Coulomb square. Next is called as a E. Its having unit is called as a Q1. You can also place that A1 and T1. Capital G is called as our gravitational constant, or it is called as a Newton's constant. So its dimensional configuration is called as M-1, L3 and T minus 2. Let's say next one is called as a mass of electron. It is only having unit kilograms, so it's only holding M1. Mass of proton, same thing, it is called as a mass of a proton. Thus we can also have M1. Now we want to show that our original part K square, G mass of electron and mass of proton, it is called as a unitless. So we are putting all those previous above values in this part. We can have value of K, it is called as M1, L3, T minus 4 and A minus 2. A1 T1's square. We can have a M minus 1, L3, it is plus 3, T minus 2, and we can have M2 because I have placed that mass of electron, mass of proton, it is M1 and M1's square. So we can have only M0, L0, T0, A0. You can see that 2 and minus 1 and this is also M1 cancelled out, L3 going in the numerator, L minus 3 0, T minus 4 T2 that would be T4 again cancel out, and 8 minus 2, and here over we have a plus 2. So we can have M0, L0, T0 and A0. So it is called as dimensional configuration less, or you can say that DC less, or it does not contain any type of unit and dimensional configuration. Next is called as a value point of view. We have to find it out so values, because they have asked us what is the ratio, and it is signifying us that is unitless, because we have proved over here it is unitless and dimensional configuration less. I want to find it out so values. Again, same in front of a K, I am putting its a value that is called as a 9 cross 10 to the power 9 is the value of K. In front of electron it is called as a 1.6 cross 10 to the power minus 19. I am not putting any type of unit because I only required of values. Capital G is called as 6.67 cross 10 to the power minus 12. Again all those units are on their terms of MKS. Mass of electron is called as a 9.1 cross 10 to the power minus 31 kilogram, and mass of a proton is a 1.67 cross 10 to the power minus 27 kilograms. Now putting all those things in the formula beside, K is square, capital G, mass of electron and mass of proton. It's a value we are finding it out. Value of K is 9 cross 10 to the power 9, 1.6 cross 10 to the power minus 19 square. G is called as a 6.67 cross 10 to the power minus 12. Mass of a proton, that is called as a 9.1 10 to the power minus 31, and 1.67 cross 10 to the power minus 27. Putting these values together, we will have a 2.29 cross 10 to the power 39. You can just score it as a 3 cross 10 to the power 39. Again, I am putting only units and dimension configuration. Unit on the left hand side because I am finding it out unit part, and another part is called as a value part. So I have found it out. It's a unit is unitless quantity. So here I am finding it out the value. It is around 2.29 10 to the power 39 or 3 cross 10 to the power 39, but again it is unitless quantity. So you can say that the ratio signifies that its a value is 3 cross 10 to the power 39 and it's a unit. It is called as a unitless quantities. Another theoretical part, I have just taken two examples together. One is called as a 1.4 and 1.5. Both are asked that when the meaning of a statement of electric charge of the body. We want to find it out that explain the meaning of the statement of electric charge of the body is quantized. We have already discussed in the previous part and the call as a formula part. It is dealing with the formula, very first formula. If you remember, so it is called as a charging by ionization method, Q equals to plus or minus Ne. So ionization can be done by the formula. It is called as a plus or minus Ne. It is quite simple, obvious. Second part, why can ignore quantization of electric charge when dealing with the microscopic or large scale charges? In physics, we have a two type of quantities. It is called as a one is called as a microscopic and another thing is called as a macroscopic. Microscopic and macroscopic part. Microscopic is called as a very smaller or very tiny in size, and macroscopic is called as a very huge size. If we want to deal with the microscopic part, we have to use that Coulomb's law, and if you want to use that macroscopic, we have to also deal with the Newton's law. If we are using Coulomb's law and Newton's law, it is dealing with the micro and macroscopic part. So we can use that Q equals to plus or minus Ne. So why we can ignore quantization of electric charge? Because electrons charge is very much micro in nature, and for that Coulomb's law. So you can also use that Coulomb's law's limitation, because Coulomb's law's limitation is there are two limitations widely used. Very first one is that it is applicable to the very tiny charges, and second one is that whenever two or more than two charges are there, we have to use superposition theorem. Sorry. Next part, microscopic and then macroscopic. Same is the cause. Newton's law we have learned in 11th science, because our microscopic levels are there because of the giant systems are there. Likewise, mass of the earth or mass of the moon or sun, whatever. So this is the thing which is called as we cannot use quantization of charges or for the microscope. It is used for the microscopic part. Exercise example number 1.5 is saying us that whenever a glass rod is rubbed with the silver cloth or silk cloth, charges appear on the both the side. Similar phenomenon is observed with the many of the other pair of the body. Explain how this observation is consistent with the law of conservation of charge. Yes, it is a supernatural law of it is called as a law of conservation of charges, same as the law of conservation of energy. So we can use that whenever charges are removed or charges are leaving, same amount of charges are also been there. In a universe, the amount of charges remains constant. Next example is called as a 1.6. I can solve this example with the two general mathematical methods. Very first one is called as a very simple method. It is useful for solving such type of examples in competitive exams, and another part is called as a one of the laborious method. Laborious method is there, but whenever you are solving such type of example for the 3 marks in your boards exam or your school exam, always solve with the conventional method, but whenever you are approaching for the competitive exams, go for the shortest one. First of all, I'm drawing this. I have 4 charges placed on each corner of the square. On the A, I have a 2 microcoulomb. On the point B, it is called as a minus 5 microcoulomb. On the C, it is called as a 2 microcoulomb, and on the D, it is called as a minus 5 microcoulombs. Very first simple method which I am supposed to show you that is, whenever you have, only follow 2 simple steps, and on the third step you will come to your answer. Very first step is that whenever you have a 2 diagonals, on this diagonals our charges are equal in sign and its magnitude, so you can just use this word equal charges. And next part is that it is located at diagonal side. Whenever our charges are equal and opposite in polarity, or maybe same in a polarity and diagonal. Whenever opposite in polarity, then it would be a quite difficult one, but whenever we have a same amount of polarity, then we can say that it's an equal charge diagonal part, so same amount of a force can be applied on every corner to the center. So we can say that from A to the point charge Q, which is placed on the center, which is 1 microcoulomb over here, so same amount of force exerted upward. For upward I am taking positive, and a downward, so same amount of force has been there, so both are nullifying the effect of each other. Same is the case for the B and same is the case for the D. Our force from the B to the center is called as a minus 5 microcoulomb, to the center is called as a 1 microcoulomb, and from the D to the center is minus 5 microcoulomb, to the center is called as a 1 microcoulomb. So I can say that our force will be same in nature, so we can say that our net force will be 0. This is quite short method and it is useful for only competitive exams. But the one of the part that is called as a laborious method, and that is called as our charges which are same thing, A, B, C, D. It is a 2 microcoulomb and it is minus 5 microcoulomb. It is again 2 microcoulomb and again minus 5 microcoulombs, and net amount of a force it is called as a 1 microcoulomb. As I have assigned that from the center, I am using this part. Okay, every side contains a distance that is called as a 10 centimeter. The amount of a force from the corner to this part, and the corner to this part, and the corner to this part, and the corner to this part, I am using this part O. So distance from OA or OB or OC or OD is called as R. You can use Pythagoras and apply and find it out a distance R, but I am suggesting you not to go for this such type of a labor, because it is not solving your purpose. Without finding it out distance, it will give you the answer. Let's see how. I am using this part F, force from A and O. I have a K, QA, QC divided by R square. You are aware that our charge is called as a, I am putting K as it is a 2 microcoulomb, and from the center it is a 1 microcoulomb and divided by R square. Force between the B and O, K, QB, QC by R square, it is minus, because it is we have a B is called as a minus 5. So minus K, 5 microcoulomb, 1 microcoulomb divided by R square. F, which is diagonal side of A, we can have a K, 2 microcoulomb, 1 microcoulomb divided by R square. I am putting negative sign. I can just say that negative sign indicating opposite side. That is called as opposite force compared to the A. And I have F of, that is called as a D of O. D of O is also having minus K, 5 microcoulomb, 1 microcoulomb divided by R square. Again I am putting negative sign, so it would be negative and negative, it would be positive. So now I am adding them together. F equals to F of AO, F of BO, F of CO, F of DO. So net force will be giving us answer 0.